Hey everyone, and welcome back to the channel. Today, we dive in deep into a fault code that many of you flying with FADIC-equipped Rotax engines have probably encountered at some point. The map sensor out of range or manifold pressure fault. It's one of the more common codes, but don't let its frequency fool you. Understanding it is crucial for maintaining engine health and ensuring safe flights. So, let's get right into it. First off, what exactly is this fault telling us? In simple terms, your engine's computer, the FADIC, is getting a manifold pressure reading that just doesn't make sense. The value is either higher or lower than the expected range for the current operating conditions, like engine RPM and throttle position. The FADIC is constantly cross-referencing data to make sure everything is running smoothly, and when the manifold absolute pressure, or MAP, sensor gives a signal that's out of whack, it throws up this flag. So, where do we find this critical component? The map sensor is typically mounted on or very near the engine's intake manifold. Its job is to measure the pressure, or vacuum, inside that manifold. This measurement is vital because it tells the FADIC how much load is on the engine. A low pressure, or high vacuum, means the engine is at idle or low power. As you open the throttle, the pressure inside the manifold increases, getting closer to the outside atmospheric pressure, which signals a higher power setting. The FADIC uses this data, along with RPM and other inputs, to precisely calculate the right amount of fuel to inject, and the perfect ignition timing. When this reading is incorrect, it can lead to poor engine performance, rough running, and incorrect fuel mixtures. Now, let's talk diagnostics. You've got the fault code, you know what it means, so what's the first step? Always start with the simplest and most common culprits. In this case, that means inspecting the vacuum hoses. The map sensor is connected to the intake manifold by a small rubber or silicone hose. This hose is your number one suspect. Over time, these hoses can become brittle, cracked, or loose. A tiny crack or a loose fitting can cause a vacuum leak, leading to false readings. Carefully inspect the entire length of the hose, from the manifold port to the sensor itself. Check for any signs of cracking, hardening, or swelling. Give it a gentle wiggle at both ends to make sure the connections are secure and not leaking. Sometimes, the problem is as simple as a hose that has popped off, or a clamp that has come loose. This is a 5-minute check that can save you a lot of time and money. If the hoses look perfect and the connections are solid, our next step is to look at the electrical side of things. The map sensor is an electronic device, and it needs a stable power supply to function correctly. We need to check the sensor's voltage. Most Rotax map sensors operate on a 5-volt reference signal from the FADIC. You'll need a multimeter for this. With the ignition on but the engine off, you can backprobe the sensor's connector. Be very careful not to damage the delicate pins or the wiring. You should find a pin with a steady 5 volts, a ground pin, and a signal pin. The signal wire is the one that sends the variable voltage back to the FADEC, corresponding to the pressure it's reading. A key thing to check is the stability of that 5-volt reference. If it's fluctuating or if it's significantly lower or higher than 5 volts, you might have a wiring issue or, in rarer cases, a problem with the FADIC itself. Also, check the ground connection to ensure it's solid. A bad ground can cause all sorts of strange electrical gremlins. So, you've checked the hoses, they're good. You've checked the voltage, and you have a stable 5-volt reference and a good ground. What's next? Now we need to evaluate the sensor's output data. The best way to do this is with a diagnostic tool that can read live engine data from the FADIC. With the engine off and the ignition on, the map sensor should be reading the local atmospheric pressure. You can compare this reading to the current meter or your altimeter setting to see if it is in the ballpark. For example, at sea level on a standard day, it should read around 29.92 inches of mercury. Next, start the engine and observe the data. At idle, you should see a significant drop in pressure, indicating a high vacuum. As you slowly and smoothly advance the throttle, you should see the pressure reading increase in a corresponding smooth fashion. If you see the data jumping around erratically, spiking, or dropping out intermittently, that's a huge red flag, unstable or jumpy data. Even if the hoses and wiring are perfect, almost always points to an internal failure of the map sensor itself. The delicate sensing element inside can fail over time, leading to these erratic signals. If you've gone through all these steps and the data is still unstable or clearly incorrect, it's time to replace the map sensor. It's generally a straightforward process. Just disconnect the electrical connector, remove the vacuum hose, and unbolt the sensor from its mounting bracket. When installing the new one, make sure any O-rings or gaskets are properly seated to prevent leaks. It's also a great time to replace the vacuum hose as a preventive measure, especially if it's more than a few years old. They're inexpensive and can save you from future headaches. After replacement, clear the fault codes and run the engine again while monitoring the live data. You should now see a stable, logical pressure reading that responds correctly to throttle changes. And that's it. You've successfully diagnosed and fixed the map sensor out-of-range fault. I hope this detailed walkthrough was helpful. Remember, always follow the maintenance manual for your specific aircraft and engine. Working methodically from the simplest to the most complex potential cause is the key to efficient troubleshooting. If you found this video useful, please give it a thumbs up. And don't forget to subscribe for more aircraft maintenance tips and tricks. Fly safe, and we'll see you in the next one.